Students, how you all? So students, we have reached now at the end of our chapter atoms and molecules, right? So in this chapter we have learned so many theoretical part, Dalton's atomic theory, limitations. We have learned a lot of definitions as atom, molecule, molecular mass, atom, molecular mass or the atomic mass, similarly average mass, ion, cation, anion. So this is the last topic of the chapter, which is called mole concept. Mole is a unit like the other units we used to do the calculations. It is just like a unit, like the dozen, like the kilogram, kilometers, etc., etc. Right? Now, what is its relationship with the atomic mass as well as the Avogadro number? Students, to do the numerical problems, we are always making it very easier by knowing the mole concept. How it is? 1 mole is always equal to Avogadro's number, that is 6.022 into 10 raised to the 23 particles. This is called Avogadro number. It is also equal to gram atomic or molecular mass of a substance. That substance may be any, may be an element or a compound, right? Means what to sum up as 1 mole of every element might be possible: hydrogen, oxygen, uranium, or it may be a molecule of the sulfur dioxide, water, sodium chloride, sugar, sucrose, whatever is there. All they have same number of molecules or atoms in the form of the Avogadro number. 1 mole of a substance. It can also be compared with the gram atomic or molecular mass of that particular substance. Again, the substance may be a compound or an element. So, how we are just going to do the numerical problems? Out of these three, that is 1 mole is equal to Avogadro number is equal to gram atomic or molecular mass. In every numerical, we have to equate any two quantities, right? Here it will be clear by the examples which we are just going to discuss about, right? For example, first is find the mass of 10 moles of sodium sulfate. Na2SO4 is the formula of sodium sulfate. Now students, if the molecule is given, right, means a formula is given, first of all we need to calculate its molecular mass. That is molecular mass of sodium carbonate. It is 2 into 23 is the mass of the sodium, plus carbon have 12 mass, plus O3. Atomicity is 3 into 16 is the mass of oxygen. It is coming 46 plus 12 plus 48. That is ultimately by adding it comes 106 grams. Means 1 mole of sodium sulfate is equal to 106 grams. Here in this numerical, we have to equate the mole as well as the gram molecular mass, right? We don't need the Avogadro number, especially in this numerical. I hope it's clear. So in the simple way as we used to do the calculations in our junior classes, we used to do for multiplication. That is 1 mole of sodium carbonate, it is equal to 106 grams, right? And 10 moles will have 160 grams, right? So this is about the solution. It is sodium carbonate, right? It is about, right? Now next is how many moles are there in 22 grams of carbon dioxide. Now just a reverse statement is there. Initially we were given with the mole 2 times. 1 mole we know, we can compare it with the molecular mass. Second is 10 moles were given in the statement. Now whatever the quantity is given 2 times should be kept in the left side. What is to be calculated should be put on the right side. So means first of all molecular mass of carbon dioxide. This will be 12 plus 32 is equal to 44. Now 44 grams of carbon dioxide is equal to 1 mole. 22 grams of carbon dioxide is equal to, by calculating, it is coming 1 upon 2, that is 0.5 moles, right? Just reverse of it, right? Now the third type of numerical in which calculate the number of molecules of S8 sulfur molecule present in 16 grams of solid sulfur. right? Again, we have to calculate molecular mass of S8. 32 into S, 32 is the mass of sulfur. It is coming 256 grams, right? Now, here what is required to compare? No need to compare now the mole. Here it will be Avogadro number because we need to calculate the molecules. So Avogadro number will be compared with the molecular mass. So 256 grams of sulfur contains 6.022 into 10 raised to 23 molecules. 16 grams of sulfur will contain, do the calculation, 6.022 into 10 raised to 23 upon 256 into 16. After calculation, it is coming 3.76 into 10 raised to 22 molecules. So again, we are having a statement. It's slightly complicated than the easier one, right? Ultimately, all the numerical related to molar concept, molecule, mole, it is quite easy, right? That is, calculate the number of aluminium ion. Now, students, the word comes here, aluminium ion, present in 0.051 grams of aluminium oxide. Means which elements are present in the formula? It is aluminium and oxygen. But we need to calculate for only aluminium, not for oxygen. So earlier also I have told you people, in the formula, aluminium has atomicity 2 and oxygen have atomicity 3, right? So again, we are going to calculate the molecular mass of aluminium oxide. Aluminium has mass 27, that is 2 into 27 plus O3 we have calculated so many times, it is coming 48. After adding, it is coming 102 grams, right? So 1 mole of aluminium oxide is 6.022 into 10 raised to 23 atoms or ions, right? An Avogadro number, it is same as in the case of element, it is the atoms. In the case of formula, it may be ions or it may be molecules. So 102 grams of aluminium, first of all, we need to calculate for the full formula. Then we will calculate for separate aluminium. That is 102 grams of aluminium oxide will have 6.022 into 10 raised to 23 ions, 0.051 grams, or we may write it for avoiding the complication in the numerical, right? 51 into 10 raised to minus 3. Right? Because it's in decimal, minus 3 grams. It is coming 6.022 into 10 raised to 23 upon 102 into 51 into 10 raised to minus 3. To avoid the complexity in the calculation, we have just turned it. 51 will be cancelled by 102, that is 2. Again, it will be calculated. It is coming 3.011 into 10 raised to 20. 23 minus 3 will be 20 ions, right? Now we need to calculate for aluminium ions. In the formula, how many aluminium ions are there? There are 2. So it is coming for 1 mole of aluminium, or the formula. For 2, it is coming 2 into 3.011 into 10 raised to 20, and it is coming again 6.022 into 10 raised to 20 ions. So student, this finish your chapter atoms and molecules. I hope you are going to do the practice for another number of numericals related to the mole concept. Thank you, students.